Hello grade 12s. We're going to be continuing with problems involving compound and double angle formula, working from slides 13 to 15. I'm just going to read the question to you where it says PQ is a vertical tower. PS and PR are cables of equal length. So I'm just going to mark that as equal over there. Anchored in the ground at points S and R. S, Q, R are in the same horizontal plane, meaning they're on a flat surface. The angle of elevation of the top of the tower P from R is theta, meaning from the flat surface going up, that angle is theta. PSR is 90 minus theta, and PQ is X meters long. They want us to show that the area of this front triangle here, SPR, is equal to x squared over tan theta. So what I've done is I've just broken it down into two-dimensional shapes. We have this front triangle, PSR, there it is there, and I'm just going to mark that this side is equal to this side from there. We also have the side triangle here, the PQR triangle, PQR, with the information inside it, that being X and that being theta. I'm not interested in this bottom triangle or the triangle behind there, as it doesn't have any of the information that we need. So this is the triangle that we want to work out the area for, and we can see that it involves an X. The only place that we have the X is with this triangle. So we need to link the information from this triangle to this one. And how we do that is with this side PR. That is the common side between these two. So because this is a 90-degree triangle, we can use our trig ratios. And if we have a look here, this is the side that we want. And this is the side that we know. So from the angle given, we have an opposite and a hypotenuse. So the trig ratio with those, the combination of opposite hypotenuse is sine. So we know that sine theta is equal to PQ over PR. To get the PR on its own, I'm going to multiply up by it and then divide by the sine. So we get PR is equal to PQ over sine theta. Now we know what PQ is. PQ is X. So we get PR is equal to X over sine theta. Now that we know what the length of this PR is, I know that this here is also PR. So this is going to be X over sine theta. And because this side is equal to that side, this will also be X over sine theta. Now, this is a non-90-degree triangle, so we can't use the common formula to work out the area of a triangle, which is a half base times height. We are going to have to use the area rule. And before we can use the area rule, remember, to use the area rule, we need the side, and the inclusive angle, the angle between the two sides that we know. So we need to calculate what this P angle is over here. Because this is 90 minus theta, and these two sides are equal, this one must also be 90 minus theta, angles opposite equal sides. So now what I can do is I can work out that P angle over there. So P would be equal to 180 minus 90 minus theta minus 90 minus theta. Angles in a triangle. Okay, so we get P is equal to 180 minus 90 falls away. That will give us plus theta, which gives us 2 theta. So now we know what that angle P is. It's 2 theta. So to work out the area now, I'm just going to write out the area formula. So it's area triangle SPR is equal to a half. Now it's the two sides that we know and the inclusive angle. So it's going to be times by PS times by PR times by sine of the angle. And that angle there is 2 theta. Let's just fill in all the information. So we get a half. PS is x over sine theta. Times by PR, which is also x over sine theta. Multiplied by, now what I can do here is I can expand my sine double angle. So I get 2 sine theta cos theta. I'm just going to simplify this. So the 2, or this half, will cancel with that 2, and we're left with x squared over sine squared multiplied by sine theta cos theta. That sine will cancel with one of the signs over there, and we are left with x squared cos theta over sine theta. So we are almost there. We just need to get that tan. What I want you to note, grade 12s, is that tan theta is equal to sine theta over cos theta. So that means if I invert this and I get 1 over tan theta, I must invert that side as well. So we get cos theta over sine theta. And that is what we have here. We have cos theta over sine theta. So this will become 1 over tan. So we get x squared over tan theta, which is what they wanted. And we have proved it.